In this video, we are going to learn about the angles property on parallel lines. What are parallel lines? Parallel lines are two lines that will never intersect each other if you keep on drawing them. Okay, so if this line is divided by a third line, that third line is called a transversal line. Okay, so the first theorem is called corresponding angles on parallel lines are equal. So when the two parallel lines are cut by a transversal line, the angles in the corresponding positions are equal. What are corresponding? Corresponding take the shape of the letter F. Okay, so if you take F, okay, the inside of the F, C and G, they are equal. If you take the reverse F, okay, D and H are equal. If you do the upside down F, okay, A and E are the same and B and F are the same. Try to imagine it, okay? Okay, if you can imagine that, then we will continue with our first example. We are going to find angle X and Y, okay, angle X and angle Y using geometric reasoning. So let's do it, okay? So angle X, if you look at the F, the inside of the F, so angle X is very simple. Angle X equals to 112 degrees. There's no working required, so automatically you know there is corresponding angles on parallel lines. They are equal. Make sure you put the word parallel line, because if they are corresponding and if not on parallel line, it is not equal. Got it? Great. Now to find Y, X and Y, they are angle on a straight line. So angle X plus angle Y, they must add up to 180. Why? Because they are angle on a straight line, they add up to 180. So if you know X is 112, so angle Y equals to 180 minus 112, because X is 112, you can get the answer as 68 degrees, and that will give you 2 marks in the exam. Got it? Great. Now we will look at the second example. The second theorem for parallel line is called alternate angles on parallel lines are equal. Okay? So when two lines are cut by a transversal line again, the angles in the alternate position are equal in size. Previously, corresponding is F shape, alternate is Z shape. Okay, so Z A equal to X, and the other Z B equal to Z. The inside of the Z, they are the same. Okay, so now we will look at another example. Okay, so now we're going to solve X and Y. So first away, you can see the Z, the reverse Z, X is the same as angle X equals 110 degrees, because they are alternate angle on parallel lines are equal. Make sure you put the word parallel lines in your exam. Okay, once you know X is 110, you can easily find Y, because angle Y plus angle X, which is 110 degrees, they must add up to 180, because they are angle on a straight line. They add up to 180 degrees. And finally, to solve for Y, you just take 180 minus 110, angle Y is 70 degrees, and again, that will be 2 marks in the exam. Okay, great. Now we shall look at the third and final theorem for parallel line. The theorem states that the co-interior angles of parallel lines they are not equal, but they add up to 180. Co means combine, two angles. Interior means inside. The two angles combine to add up to 180. So A plus Y is going to add up to 180. B plus X is also 180. And the theorem is the co-interior angles of parallel lines, they equal to add up to 180. So we shall look at the example now. You are supposed to find X and Y. So first, angle X plus 70 degrees, okay? They must add up to 180, because they are co-interior. They are parallel, the inside. So you must put the reason co-interior angles on parallel lines equals to 180. They add up to 180. So angle X equals to 110 degrees, because 180 minus 70 will give you 110. To find your Y, they are vertically opposite angle. Okay, so angle X is equal to angle Y. This is equal to 70 degrees. Okay, because they are vertically opposite angles are equal. So technically, you have learned three important theorems today. The first one is called corresponding angles on parallel lines are equal. They take the letter F. The next one is the alternate angles on parallel lines. They are also equal. They form the letter Z. And the last one is the co-interior angle. They are not equal, but they add up to 180. They take the letter C. Okay, the inside of the C or the reverse C. So hope you learn this theorem and ace in your exam. Cheers, everyone.